Hi guys, today we're going to be looking at Pythagorean Theorem. We're going to be learning what the formula is and how to apply it to certain problems. Okay, so let's go ahead and take a look at this first picture that we have here. If you see, we have a right triangle and we also have these three different squares. So way back when they came up with this formula that's called Pythagorean Theorem, what they saw is if they created these squares on the top, bottom, and right, and they found the area of each, they found a relationship between these squares. So let's see what that relationship is. First, let's go ahead and take a look at this first square. We're going to go ahead and find the area of C. It's a 5 by 5. If you count 5 this way and 5 this way. So we know that the formula that we use to find the area of a square is base times height. So let's go ahead and do that. This is a 5 by 5. So if we found the area 5 times 5, which is 25. Let's go ahead and find the area of A now. A is this square down here. So this is a 4 by 4. So to find the formula, we're going to do base times height again. 4 times 4 gives me 16, and I know that's the area of square A. So far this is what we've got. We've got 25 for this one, 16 for this one, and let's go ahead and do square C. Square C is a 3 by 3, square B is a 3 by 3, so 3 times 3 gives me 9. So I know that the area of this one is 9. Okay, so what I want you to do right now is look at this picture and see what kind of relationship do you see? There's something going on here. What pattern could I do? What could I do with this number, the 16, and the 9, and to get 25? So go ahead and pause the video, think about this, and see if you can come up with an answer. Okay, so I hope you were able to find some sort of relationship. The relationship that I saw is that if you added the 2, you ended up with C. So if you added the area, which was 16 and 9, if you added those two, you ended up with the area of square C. And that's a relationship that way back when they figured out this formula, they did a bunch of different right triangles, and they noticed this relationship happen every single time that there was a right triangle. So that's how the formula Pythagorean Theorem came to be. So we came up with this formula, which is a squared plus b squared equals c squared. Now, I know it's sometimes hard to remember formulas. Therefore, instead of trying to memorize this, I want you to think of the area of square A plus the area of square B equals the area of square C. And that's how we're going to approach every problem that we come up with. Okay, let's go ahead and take a look at this first problem. Like I said, every time we have a problem, guys, I want you to remember area of one plus the area of the other equals the area of that slant height, which is the C. So let's go ahead and set this problem up. The first side, if you were to draw a side here, it would be this one. Let's go ahead and make that square A. So my square A is a 6 by 6. And I'm going to add it to the area of square B. Remember that B is the other one. No, that's something very important that you need to make sure you understand. C is always the diagonal. Always going to be the diagonal. And the way I want you to remember it is anytime you forget to remember that that's the diagonal, you always see, I'm the biggest. And that's what you're going to do in case you don't remember. That's the easiest way to remember. The C is the C, I'm the biggest, and you make a diagonal with your hands. So right now we have B, which is a 2 by 2 square. And I'm sorry, mine looks like a rectangle, but it's supposed to be a square. And then in the diagonal, that's my C. It's the biggest one, and so we don't know the C. Right now, we just want to know what the area is. We want to know what this area is. So let's go ahead and do our steps. We know that the formula for square is base times height, so let's go ahead and do it. 6 times 6 is 36, and 2 times 2 is 4. So now I'm just going to do my steps. 36 plus 4 is 40. So what I found right now is that the area of the square C, this one over here, is 40. Now, normally what they want is not the area. They want to know what are the side lengths. What are these side lengths of this square? Because that's what we're trying to find, the side length, the diagonal. So we're going to have to do one last step. Now remember, guys, that the opposite of something being squared is the radical, is the square root sign. So that's what we're going to do. If I get the square root from both sides, I can find what C is. C is going to be the square root of 40. Now, of course, I don't expect you to solve this out by hand. You could do this in your calculator, and you can find what the square root of 40 would be. Okay, let's go ahead and try this example. Now, if you notice, this one's a little bit different than the previous one because we have one side, and we have the diagonal. The one that we're missing is that bottom part. So this one's a little bit different. What we're going to do is still going to be setting it up the way that we talked about. Area of one plus the area of the second one equals the area of the diagonal. So let's set it up that way. We have square A, which is going to be this one. It's going to be a 5 by 5. And then I have square B, which is this bottom one. I don't know it, but I'm still going to draw it. And then I have square C, which is the one up here, and we do know that side. It's a 10, so this is a square that's a 10 by 10. Okay, so let's go ahead and find the area of those that we can. So let's say for this first one, 5 times 5, we can find the area. That's 25. I don't know that second one, so I'm just going to go ahead and leave it blank. I know the area of C because 10 times 10 is 100. So far, all I know is that 25 plus something is equaling 100. Well, let's go ahead and find that area. We know how to work backwards. I need to subtract 25 from both sides so that I can find what that area is. If I take away 25 from both sides, I end up with the area of this square ends up being 75. So this area we got to be 75. Now here's where you need to look back at your question. What were they asking me to find? They weren't asking for the area. They want just B. What is B? So what is that side length? So just like the previous one, what we've just found right now is that the area, or B squared, is 75. Let's go ahead and solve for B. What's the opposite of this little exponent? Well, the opposite is finding the square root. So let's go ahead and find the square root. If I take the square root of both sides, I will now have the side length B. So right now, I know that B is the square root of 75. And again, this is not a perfect square, so you could plug this into your calculator and you now know what B is. And that's it, guys. We're going to see these two kinds of problems. Problem number one, where you know the A and the B, the two squares that are on the base and the height of the right triangle. And then you find the area of the diagonal. And the second kind of problem, which is like this one, where we know one of the sides, we don't know the bottom, or we don't know the height of the triangle, and we do know the diagonal. So there always has to be one missing. We need to know either the base and the height, or the base and the diagonal, or the height and the diagonal. At least two of the sides of this right triangle you need to have.